es Becka.
Mi nombre es Pablo.
My name's Sam.
Thanks for watching us on DPS TV. Hi, today we're going to work a little bit on exponent properties. This is definitely a topic that through my teaching high school career, I've noticed that a lot of my students don't know a lot about, or it tricks them up a lot. It doesn't even matter what level they are at. So we're going to talk about it a little bit. Hopefully I can clear up some of those misconceptions and some issues or confusions. All right, so if we cut to my screen, let's first talk a little bit about vocabulary with exponent properties. I have this x to the 5th power up in the corner here. Exponent properties, or in other words, exponents, are also known as powers. So we can call them powers or exponents. And those are the little numbers you might see on the top right of the number in small print. And we'll talk about what that means in just a second. The variable or the number that has the power is called the base. I kind of sometimes refer to this as the big number or the big variable. It's the base. And really what an exponent is telling you how many times you are repeatedly multiplying together that base. So for example, if I were to write, and I'm going to write this out here, if I were to write this in expanded form, think of it as like an accordion. I'm kind of writing it out as x to the 5th as x times x times x times x times x, 5 times. So I'm kind of expanding it and pulling it out. And that's what that power means, is how many times I'm repeatedly multiplying together the base. So there are a couple properties that we can learn about, and properties in math are really just shortcuts. Properties are patterns that were noticed, and then a shortcut is applied so that we don't have to do the long way every time. So let's go first look at this first example here. It says x squared times x to the 3rd. We can simplify this expression by using what's called the product of powers property. And what we're going to do first to see how we can simplify this is we're going to start by expanding it. This would be one of my tips if you are ever having trouble remembering the properties, because honestly, let's be real, in math there are a lot of rules to memorize. If you can avoid memorizing rules, usually that's better to help you learn. So if we expand it, because we forget the rule, then you can try to figure out the rule. In fact, I will tell you these first 2 rules that we're going over, I could not remember for the life of me in high school which one was which. So what I always did on my test is I would write these examples and I would expand them and figure it out for myself. So if I were to expand x squared, so just x squared, I can do it just like I did in the first example where I just write it as x times x. There's a times in between there, so we're going to multiply that by x to the 3rd, which can be written as x times x times x. What you may notice is that, so we kind of pulled apart our accordion. To simplify, we want to put the accordion back together. And so we're going to simplify this x times x times x times x times x, and we can call that x to the 5th. What I would hope that you would notice, and I'll get my highlighter so you can see what I'm talking about, is let's say I have something with the same base, and the powers, we want to simplify, we're multiplying them and we want to simplify it. We want to think about how 2 and 3 are related to each other. Well, if you take 2 plus 3, we get 5. So the product of powers property in general form is written like this. If I have x to the a power times x to the b power, the way that simplifies is we just say that it's x to the a plus b power. So whatever a is, we're going to add it to b, and that'll be our new power. So that's the product of powers property. The next one is going to be the power to a power property. This one we'll also figure out by expanding. So if you think about what's inside of these parentheses, I'm going to just leave the parentheses here, leave my 3 on the outside. I've got x squared on the inside. That means I've got x times x on the inside. This power on the outside, this 3, is saying that what I'm doing is I'm taking everything in its parentheses and multiplying it by itself 3 times. So I can expand that part. So therefore I've got x times x times x times x times x times x. We can put that together, so we kind of pulled our accordion apart. We want to simplify it, so we'll pull that accordion back together, and you will notice that we have 6 x's being multiplied together all together, so I have x to the 6th power. Now back to the shortcut, because that's the whole point. I had started with x to the 2nd power to the 3rd power, and I ended up with x to the 6th power. So what you may notice, the relationship between 2 and 3 is that we multiply those powers together. So writing the shortcut to this, I would say x to the a power taken to the b power is going to end up being x to the a times b power. So there's our shortcut. I'm going to go ahead and draw a box around my shortcuts just so we have those kind of marked out. So there are 2 of our properties. And again, you can probably even figure out the rest on your own by expanding each of these expressions to start with. So let's do that same with this one. This is called the quotient of powers property, meaning we're dividing. So if we're dividing 2 things with the same base, we can, well, I'll show you the shortcut. So x to the 3rd is split up as x times x times x. X squared is split up as x times x. Now one thing that we want to consider is that when we have a value divided by itself, like this, and I'll give you an example, maybe 4 divided by 4, or 3 divided by 3, we always end up getting 1. So this, x over x, turns into a giant 1. It's just 1 times all of this. This also turns into a giant 1. So really what I have here is I have 1 times x. And right, we know that 1 times anything is just itself, so we're left with x. So essentially, x over itself, or anything over itself, cancels, but the reason it cancels is because it turns into 1. So back to then the shortcut. The shortcut can be found, and we'll highlight our numbers here. We have 3 on top, 2 on the bottom, and then our power at the end is actually, it's not written, but when it's not written, it's understood to be a 1, because we have 1. So 3, 2, and 1, the way those are related is with subtraction. So we'll always take the top power minus the bottom power, gives us our new power. So we'll write that rule out. So we have, if I had x to the a power over x to the b power, the way to simplify it is I take x and I do a minus b. And that is our quotient of powers property. A couple of the others deal with if we have more than one base. So an x and a y, we can't maybe put them together. But again, we can figure out how to simplify this by expanding it. It seems kind of counterintuitive. It's like, make it more complicated before you make it simple, but it works. So again, this 2 power here, it means that we are going to do whatever's in our parentheses twice. So I'm going to be doing x times y times x times y again. We expanded our expression, now we want to put our expression back together. If you notice, I have 2 x's, so that would give us x squared, and I have 2 y's, so that'll give me y squared. I cannot put my x's and y's together. They are not like terms. They are not the same base at all, so I can't put them together. This is as close as I can get. So what you may notice, the pattern in this one is that what we do when we have a power outside of parentheses is that we apply our power to every base that we have. So I applied it to my x base and I apply it to my y base. It gets applied to both. So to generalize this, I can say if I have x, y to the a power, I will simplify this by having x to the a power and y to the a power. So that simplifies this rule. The next rule is very, very similar. It's just with division instead of multiplication. If I had, so here's an example, if I had x to the third, or x over y to the third power, I could expand that by saying that's the same thing as x over y times x over y times x over y. Now, if you remember anything about fractions, what we do is we always multiply our top, our numerators together, and we multiply our denominators together. So on the top, I have x times x times x, which we now know that is x to the third power. And on the bottom, we have y times y times y. We now know that that's y to the third power. So similar to the property that we just saw, what you may notice is that our final simplified solution is taking that power and applying it to all the bases. Doesn't matter if they're on the numerator or denominator. So to generalize this, again, I'm going to say x over y. We're going to say to the a power. If I simplified that, I have x to the a power over y to the a power. Last couple ones. Anything to the 0 power. This is just equal to 1. It doesn't matter what it is. It's just equal to 1. Now, I would get into an explanation on this, and I can probably do it on a different episode, but that'll make this one a little bit too long. So just trust me on this. Anything to the 0 power is always equal to 1, which is kind of weird. The other one that really throws my students off oftentimes is negative powers. They always think that it's going to give you a negative answer. But really, if you think about, so positive powers are repeated multiplication. So negative powers are always the opposite of positive. Negative powers are repeated division. So what we're saying that this x to the negative third is 1 divided by x 3 times. I have this little catchphrase that I use that sometimes helps me work with this or remember what to do, is over the line and change the sign. So what we do with that is I take my base and I move it over a fraction bar, and then I make it positive. It turns into positive. So these are all of our exponent properties, and I think honestly the hardest part about exponent properties is when you are expected to apply more than one of them at a time, or if you have more than one base that you're dealing with. So let's go over a couple examples, and I can give you some strategies of how to actually deal with this whenever you have more than one property to apply. So this first example, 4a to the third power times b squared times 3a to the fourth power b to the third power. We're going to deal with this first. So what I like to do whenever I'm working with these is I like to look for same bases. So if you look here at this one, I have 4 and 3. Those are both regular numbers, we'll call them. I have a base of a, and I have a base of b. And what we want to do is we want to make sure that anything with the same bases, they get combined. So making things simpler. So when it comes to numbers, the coefficients, sometimes a lot of people have issues with those. We just treat them like normal. We have 4 times 3, so that's just going to give us 12. Over here with the a, I have a to the third times a to the fourth. Well, if you remember our product property, we are going to add our exponents. So a to the third plus the fourth, I get a to the seventh. We're going to do the same with b. Now, we don't want to combine a and b together. We want to keep them separate. We're going to add those powers, and we end up getting 2 plus 3, we get 5. So simplifying this, we have 12a to the 7th times b to the 5th power. And again, we want to make sure that in our final solution, we don't have any bases that are still the same. On to the second example. Some other thing that we should end up doing is if we have parentheses, we want to deal with parentheses. So anything on outside of the parentheses, we want to make sure we apply that to both of our bases. What I do want to mention is that the order that we apply our properties doesn't really matter. However, we do want to kind of deal with parentheses a little bit closer to first. So applying our one of our properties up there where we make sure each of our bases gets a power. So you have to consider that we have two bases here. I have a 2 and I have an x squared. So I'm going to apply that to both of them. So my 2 does not have a power right now, or you could think of the power as 1. And so our new power is going to be 1 times -4, which is -4. On our x, we have a 2 already, and thinking about our power to a power property, we always multiply those two together. So we end up getting x to the -8. The last thing that we want to make sure that we deal with is negative powers. Negative powers are never simplified. We don't like to leave them negative. So we're going to go with the over the line, change the sign. If you have nothing left on top, we call it a 1. So we're going to say 2 to the 4th power and x to the 8th power. The last little bit is if you've got a number to a power, you probably want to actually write down what that number is. So we'll do that over here. We have 2 to the 4th power, which equals 16. And there's our final simplified solution for this one. All right, last example is first we're going to do what we said here. We're going to look for same bases. So I've got regular numbers here. I call them regular numbers. We've got, we don't have any parentheses. I've got some negative powers. So maybe we'll look for our same bases first. And then I've got the z. All right. So starting with the 16 over 8, so 16 divided by 8 is going to give us 2. I'm going to put that on the top of my fraction because I don't know if there's still going to be a bottom or not, but we're going to put it on the top because 16 divided by 8 is 2. I've got x to the 4th on top divided by x squared. We can kind of take this out and just think of our quotient property, which means we subtract our two powers. So we end up with x squared. Now you've got a choice here for your y's. You can apply either the quotient property, where we subtract, or we can take our negative power and move it over the line, change the sign. I'm going to go with our quotient property since we just used it. So we have y to the 4th over y to the -3rd. We're going to do 4 minus -3, which ends up giving us 7. We'll do the same for our last one. We'll apply our quotient property. I've got -3 minus 4, and that's going to give me z to the -7th. Now we mentioned also that we cannot have negative powers. So this here, we are going to have to take over the line, change the sign. So it's going to move over the line down here, and we're going to change the sign to make it positive. So it's no longer up there. So we've dealt with our same bases, our parentheses, our negative powers. We've got it all taken care of. What I would suggest, I guess my overall advice when it comes to working with exponent properties is that, number one, order does not matter. If you recognize you have same bases, go for it at any time. Order does not matter. This is not like order of operations. Secondly, look for, take it one step at a time. So if you notice one, simplify that. Like for example, on this one over here with the x to the 4th over x squared, if you notice that and nothing else, do that first, rewrite it, and oftentimes the next steps come to you. I think part of the reason that these are difficult is because they can get, students can get bogged down with not knowing from start to finish. When they look at the problem, they don't know how they're going to get to the end. You just chip away at it one step at a time. So hopefully these explanations and these examples help you a little bit in working with these, and I would say my biggest piece of advice is practice. Practice does make perfect in this case. Hopefully this helps. Take care. Thanks for watching this episode of Tutor This. As always, if you have questions or suggestions for future episodes, leave them in the comments below. Remember to click the like button below, and if you enjoyed this video and want to see more like it, hit subscribe.